Next example, find the equation of plane passing through the point 1, 1, 2 and is perpendicular to these two planes x minus y minus z is equal to 1 and 2x plus 3y plus 0z is equal to 4. Let the required equation of plane be ax plus by plus cz is equal to 1. This is the suppose star equation star. And since this equation star passes through the point 1, 1, 2, we have what we have the point satisfies the equation, that is we have, that is substitute x as 1, y as 1 and z as 2. We have the equation a plus b plus 2c is equal to 1. Suppose this is equation number 1, this is equation number star. Then since this plane this required plane is perpendicular to these both two planes, and therefore what do we have, we have a into 1, that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0 by using condition of perpendicularity of two planes. So a into 1, that is a, then b into minus 1, that is minus b, and c into minus 1, that is minus c is equal to 0. Okay, and we have the another equation 2 into a plus 3 into b plus 0 into c is equal to 0. So these are the equation number suppose 2 and 3, and then solve this equation number 1, 2 and 3 for capital A, capital B and capital C. So write this equation as 2a capital A plus 3 capital B minus 0 plus 0c because the coefficient of z is 0 is equal to 0, and solve this equation number 1, 2, 3. This is equation number 1, this is 2 and this is 3 for capital A, capital B and capital C, and substitute these values in equation number star, we get the required equation of plane. So all these three problems are of the same type. This problem, that is find the equation passing through 3 points. Suppose the equation of plane be ax plus by plus cz is equal to 1. So we take this equation as a equation of required plane because this equation contains three unknowns, capital A, capital B and capital C. So don't take another form, that is the general form is what, small ax plus small by plus small cz plus small d is equal to 0. This is the general form of the equation, but this equation contains four unknowns, small a, small b, small c, small d, and there are three equations. So take this equation as a required equation of plane. So same we have the three equations, as these 3 points lies on this plane means these 3 points satisfies the equation of plane. We have the three equation 1, 2, 3. Solving 1, 2, 3 for capital A, capital B, capital C by using either calculator or by using augmented matrix Gauss elimination method. Okay. Similarly, the second problem is what, find the equation of plane passing through 2 points and is perpendicular to these 2 points, this plane. So as the equation again take the equation of the required plane same as capital X plus capital by plus capital CZ is equal to 1 as a star equation. This equation passes through these 2 points. We have these 2 equations because these 2 points satisfies the equation. And then as the plane 1 as the plane star, this star is perpendicular to this plane by using the condition of 2 planes to be perpendicular. So when the 2 planes are perpendicular, if the coefficient of multiplication of coefficient of x plus multiplication of coefficient of j plus multiplication of coefficient of x plus multiplication of coefficient of y and plus multiplication of coefficient of z is equal to 0, we have this. So as this required plane is perpendicular to this plane, we have a, that is the coefficient of x is a, here is 1, a into 1 plus b into 1 plus c into minus 2 is equal to 0. What do we have the equation, a1 a2 plus b1 b2 plus c1 c2 is 0 means a minus b minus 2c is equal to 0. And solving these three equations, we have the values of capital A, capital B, capital C. Substitute the values, we have the required equation of plane. Same problem is here. We are given the 1 point on the plane and the this problem. The plane is, this is the same problem. This is 1 point on the plane and is perpendicular to these 2 planes. So take the required equation of the plane as ax plus by plus cz is equal to 1. Since the plane passes through this point, so the point satisfies the equation of plane. We have this equation is equal to 1, right? Is equal to 1. Write x, y, z as 1, 1, 2. And the required plane is perpendicular to this plane. So we have this equation is equal to 0. Remember, it is not equal to 1. It is equal to 0 because the condition of perpendicularity is what? A1 A2 plus B1 B2 plus C1 C2 is equal to 0. That is the multiplication of coefficient of x, that is a into 1, that is a. Then multiplication of coefficient of y plus b into minus 1 is minus b, and plus coefficient multiplication of coefficient of z is c into minus 1 is minus c is equal to 0. Similarly, we have this. This plane is again perpendicular to this plane. We have this 2a plus 3b plus 0c is equal to 0. So solve these three equations for capital A, capital B, capital C, and substitute the values, we get the answer. Next is again important point, that system of planes. So question is, U is the notation for this equation of plane, A1x plus B1y plus C1z plus D1 is equal to 0. And another plane equation of plane is A2x plus B2y plus C2z plus D2 is equal to 0. Suppose this is denoted by U and this is denoted by V. Then prove that U plus lambda V is equal to 0, where lambda is any constant. Represent system of planes passing through the line of intersection of the two planes, U is equal to 0 and V is equal to 0. That is these two planes. That is, if the two planes intersect, then we have a straight line. The intersection of two plane is a straight line. That is the intersection part. Like if we intersect two lines, then we have the intersection of two lines is point. The intersection of two lines is point. The intersection of plane and circle is plane and sphere is circle. That is, if we cut the sphere by plane, then we have the circle. The intersection of the plane and sphere is circle. Like that, intersection of two planes is straight line. And what is U plus lambda V is equal to 0 is the system of planes. Means we have the infinitely many planes passing through the line of intersection of these two planes. U is equal to 0 and V is equal to 0. That is, U plus lambda V is the system of planes. That is, we have the infinitely many planes, and these planes passes through the line of intersection of these two planes. So U plus lambda V is equal to 0 is the formula to obtain the equation of plane passing through the line of intersection of these two planes. That is, if we change the value of lambda, we get the different equation of planes passing through the line of intersection of that two planes. U is equal to 0 and V is equal to 0. So proof of this theorem. So in the first part, U plus lambda V. What is U plus lambda V? U is this A1x plus B1y plus C1z plus D1. This is U. And plus lambda V is A2x plus B2y plus C2z plus D2 is equal to 0. So write it. Collect the coefficient of x, y, z and constant coefficient. So coefficient of x is what? A1 plus lambda A2 x. Then coefficient of y is what? B1 plus lambda B2. And coefficient of z is what? C1 plus lambda C2. And the constant coefficient is what? Plus in bracket D1 plus lambda T2 is equal to 0. And obviously this is the equation of plane. So this U plus lambda V is equal to 0 means this is the equation of plane. Why is the equation of plane? This is in the form AX plus BY plus CZ plus D is equal to 0. And so this equation represents plane. Now we have to show this equation represents a plane passing through the line of intersection. U is equal to 0 and V is equal to 0. Let P x1, y1, z1 be any point. So if the theorem is, if we take the theorem as if and only if type, then this is the part first. Then part second, we have to prove. Let P x1, y1, z1 be any point on the line of intersection of the two planes. U is equal to 0 and V is equal to 0. Okay. We have to prove we have to prove that this equation, suppose star or 1, we have to prove this equation, naming it as a star. So we have to prove this plane passes through the line of intersection of the two intersection of two planes. U is equal to 0 and V is equal to 0. That is, every point of the line lies on the plane, this plane. So take P x1, y1, z1 be any point on the line of intersection of two planes. U is equal to 0 and V is equal to 0. That is, we have the line as the intersection of these two planes, and Px1, y1, z1 is any point on the line of intersection of these two planes. And therefore we have, means this point lies on the plane u is equal to 0 as well as v is equal to 0. As the point Px1, y1 lies on this plane u is equal to 0, what happen? The point satisfies the equation. That is, we have a1 x1 plus b1 y1 uh, plus c1 z1 plus d1 is equal to 0, because p x1 y1 z1 lies on the plane u is equal to 0. Similarly, p x1 y1 z1 lies on the plane v is equal to 0. Therefore we have a2 x2 plus b2 not x2, a2 x1 plus b2 y1 plus c2 z1 plus d2 is equal to 0. That is, this point also satisfies this equation. That is, substitute x y z as x1 y1 z1. Okay, equation number 1 and 2. Then consider this equation a1 plus a2 lambda x1. That is, we have to show the point lies on this plane. Now what we have to show? This point lies on this plane. So when the point lies on this plane, if the point x1, y1, z1 satisfies this equation, so substitute x, y, and z as x1, y1, z1. Consider LHS and substitute x, y, z as a x1, y1, z1 is equal to. So LHS, substitute x as x1, y as y1, z as z1 is equal to. Don't write is equal to 0. We have to prove it is equal to 0. So is equal to, and simplify this, multiply by x1, multiply by y1, multiply by z1, and then collect the terms a1 x1, this a1 x1 plus b1 y1 plus c1 z1 plus d1 in one bracket, and take lambda common from remaining terms. We have in bracket a2 x1 plus b2 y1 plus c2 z1 plus d2, and the value of these brackets are 0 by using equation 1 and 2, and therefore we have the answer 0. Means this point p x1 y1 z1 lies on the plane u plus lambda v is equal to 0. This plane is what? U plus lambda v is equal to 0. Means every point of the line of intersection of two planes u is equal to 0 and v is equal to 0 lies also on the plane u plus lambda v is equal to 0. Means this u plus lambda v is equal to 0 passes through the line of intersection of two planes u is equal to 0 and v is equal to 0. So first prove u plus lambda v is equal to 0 is the represent plane, this part 1, that this u plus lambda v represent is the equation of plane. And now in the second part, the proof is what? That this plane u plus lambda is equal to 0 passes through the line of intersection of the two planes u is equal to 0 and v is equal to 0. So how we can show the this second part? That is, take p x1 y1 z1 as any point on the line of intersection of these two planes, and as this point lies on the plane u plus lambda v is equal to 0, we say every point of line of intersection of these two planes lies on the plane u plus lambda v is equal to 0, and that's why u plus lambda v is equal to 0 passes through the line of intersection of these two planes, and so we say that u plus lambda v is the system of planes passing through the line of intersection of the two planes u is equal to 0 and v is equal to 0. So the proof is the probability of proof is 90%, but the problem are also important on this theory. The proof of this theorem is also important, but this question is important. The probability is 95 to 99%, either theory or problem, or both, for 6 marks. So the problem is of the type, find the equation of plane containing the line or passing through the line. Both wordings are same, that containing the line or passing through the line of intersection of two planes, 2x plus 3y minus z plus 1 is equal to 0, and x plus y plus 2z plus 3 is equal to 0. So we had to prove, and passing through the point this, we have to find the equation of plane containing the line. You are passing through the line of intersection of these two planes. So the required equation of plane is u plus lambda v is equal to 0. This is the formula to obtain the equation of plane containing the line or passing through the line of intersection of these two planes. What is u? U is the first plane, that is 2x plus 3y minus z plus 1. and plus lambda, another plane is what? X plus y plus 2z plus 3 is equal to 0. So these equations are given separately or combinedly. These equations are given in this form: 2x plus 3y minus z plus 1 is equal to 0, and is equal to x plus y plus 2z plus 3 is equal to 0. One and the same. So what is the required equation of plane? U plus lambda v is equal to 0. U plus lambda v is equal to 0. So simplify this in the form ax plus by plus cz plus d is equal to 0. So collect the coefficient of x, it is 2 plus lambda, then plus the coefficient of y is 3 plus lambda, coefficient of z is what? Minus 1 plus 2 lambda z, coefficient of z, and the constant coefficient is 1 plus 3 lambda. 1 plus 3 lambda is equal to, this is equation star, and this equation, this sentence passes through the point 1 minus 2 3. This is equations, this plane star passes through the point 1 minus 2 3, and means we have this point satisfies this equation. That is, substitute x y z as 1 minus 2 3. What do we have? We have 2 plus lambda into 1 plus 3 plus lambda into minus 2 as a y value of y, and minus 1 plus 2 lambda value of z as 3 plus 1 plus 3 lambda is equal to 0. So simplify, multiply by 1 minus 2 here 3, and then we have the value of lambda as 3 by 4. Lambda as 3 by 4, and substitute this value of lambda in this equation star. So 2 plus 3 by 4 x, 3 plus 3 by 4 y, minus 1 plus 2 into 3 by 4 means 6 by 4 z, plus 1 plus 3 into 3, 9 by 4, so right, 9 by 4, or 3 to 3 by 4 is equal to 0. So this is what? 4 is the LCM. 4 to the 8 plus 3, 11 by 4. This is 15 by 4. This is 2 by 4. 4 is the LCM. Minus 1 plus 6. Minus 4 plus 6 is 2 by 4 z. Here is the 4 is the LCM. And then 4 plus 9 is 13 by 4 z. And then multiplying by 4, we have 11x plus 15y plus 2z plus 13 is equal to 0, and this is the required equation of plane. So this is the equation of plane passing through the line of intersection of these two planes and passing through the point 1 minus 2 3. So next example is again of the same type. Find the equation of plane passing through the line of intersection of these two planes and containing the point or passing through the point 3 4 and 3. So first write u plus lambda v is equal to 0, and then find the value of lambda by using this point. Next example, find the equation of plane passing through the line of intersection of these two planes and at a distance unity from the origin. At a distance unity from the origin. So in order to find, first write u plus lambda v is equal to 0. That is the equation star, and then it is at a unity, at a distance unity from origin. So what is the distance of origin from the plane? Suppose this is the equation star. What is the distance of origin from this plane? Is substitute x as 0, y as 0, z as 0, divided by root 2 plus lambda square plus 3 plus lambda square plus minus 1 plus 2 lambda bracket square. Okay, and then find the value of lambda, and it is equal to 1. Unity means 1, and so find the value of lambda. So its answer is given. Yes, here is the answer. So the answer of second equation, problem number second. So first write the equation of plane. The required equation of plane is u plus lambda v is equal to 0. So what is u? U is this x plus y minus z plus 1, and plus lambda v is what? 2x minus y plus 2z plus 3. So write that plus 3 is equal to 0, and simplify it. So the coefficient of x is 1 plus 2 lambda, y is 1 minus 1 lambda, z coefficient of z is minus 1 plus 2 lambda, minus 1 plus 2 lambda, z plus 1 plus 3 lambda is equal to 0. And now what is given? The distance of this distance of origin from this plane is equal to 1. So what do we have? Mod in mod, the distance of origin from this plane is what? 1 plus 2 lambda in mod, right? 1 plus 2 lambda into 0 plus 1 minus 1 lambda into 0 plus minus 1 plus 2 lambda into 0 plus 1 plus 3 lambda divided by this plus 1 plus 3 lambda divided by root 1 plus 2 lambda bracket square plus 1 minus lambda bracket square plus minus 1 plus 2 lambda bracket square is equal to 1, right? Is equal to 1. So what is given? The distance of at a distance unity from origin. The at a distance unity from origin means the distance of origin from the required plane is 1. So this is the formula to obtain the distance of point from origin. So what is the formula? How we can obtain the distance of point from any plane? So the formula is given here. The distance of, yes, the perpendicular distance of point P x1 y1 z1 from the plane x plus by plus cz plus d is equal to 0. What is the formula? A x1, that is replace x as a x coordinate of that point, y as a y coordinate of that point, and z as a z coordinate of that point, plus d as it is, divided by root square of coefficient of x plus square of coefficient of y, the square of coefficient of z. So use this remark or formula that the distance of point from origin and find the distance of the origin from the distance of the point from plane. So here the distance of origin, this is the distance of, this is the distance of origin from this plane, right? Here mod, don't write this equal to sign, mod is equal to 1, is equal to 1, and then simplify it, is equal to 1. So the numerator is 1 plus 3 lambda, denominator find the square of all these brackets and simplify that like this. Shift the denominator quantity, this quantity, to RHS. So 1 into this is this quantity. So LHS is 1 plus 3 lambda, 1 plus 3 lambda. RHS is this root 1 plus 2 lambda square plus 1 minus lambda square minus 1 plus 2 lambda square. So, and then square both sides and find the square of each bracket, and then add and subtract the terms of lambda square, lambda and constant. We have this equation, 18 lambda square minus 2 is equal to 0, and so lambda square is 2 by 18, lambda square is 1 by 9, means lambda is 1 by 3, plus minus 1 by 3, take 1 by 3 as a lambda, and then put this value of lambda in this equation, equation star. So we have this equation, and then 1 plus 2 by 3 is 5 by 3, multiplying by 3, lastly multiplying by 3, so 5x plus 2y minus z plus 6 is equal to 0, and is the equation of plane passing through the line of intersection, and is distance is unity from the origin. So similarly solve this problem. This problem is for assignment. So the next problem is of the same type, that is the equation of plane passing through the line of intersection of two planes. So we will see the remaining problems in the next lecture.